Welcome. Today we're diving into the fascinating world of bioplastics, materials that are changing how we think about plastic and sustainability. With growing concerns about fossil-based plastics and their environmental impact, the search for alternatives has led to the development of plastics made from renewable raw materials. But what exactly are bioplastics? Are they truly natural, and how do they fit into our everyday lives? In this video, we'll explore the science, market, and future of bioplastics, starting with what they are and why they matter. Bioplastics is a term that covers a range of materials, but there's no single universally accepted definition. Generally, it includes two main classes: plastics made from renewable raw materials, like plants or microorganisms, and plastics that are biodegradable regardless of their origin. Some bioplastics are both renewable and biodegradable, while others may only fit one category. This dual nature makes the field both exciting and a bit confusing, so let's break it down further. Understand bioplastics. It helps to look at the carbon cycle. In the short-term carbon cycle, plants absorb carbon dioxide through photosynthesis, converting it into sugars and oxygen. When these plants decompose or are used, the carbon returns to the atmosphere. In contrast, fossil-based plastics rely on carbon stored underground for millions of years, disrupting the natural cycle when released. Bioplastics aim to close this loop, using carbon that's already part of the active cycle. Bioplastics can be classified by their source and properties. Some are made from renewable resources like plants, while others are biodegradable, breaking down naturally over time. There are also fossil-based plastics that are biodegradable and renewable-based plastics that are not. This creates a matrix of possibilities, each with its own advantages and challenges. Understanding these categories helps us see where bioplastics fit in the bigger picture of sustainable material. Raw materials for bioplastics come from a variety of sources. Plants provide starch, cellulose, and lignin, while animals contribute proteins like casein and gelatin. Microorganisms can produce polyhydroxyalkanoates, PHA, and other biopolymers. Even natural rubber and vegetable oils are used. This diversity allows for a wide range of bioplastic types, each suited to different applications, from packaging to medical devices. Production of bioplastics involves several processes. Some use nature's own synthesis abilities, like extracting starch or cellulose. Others rely on fermentation to produce monomers such as lactic acid, which can be polymerized into materials like PLA. There's also thermochemical conversion, turning biomass into building blocks for plastics. Each method has its own energy and resource requirements, influencing the overall sustainability of the final product. Let's take a look at the current bioplastics market. In 2012, global plastics production reached 288 million tons, with Europe contributing 57 million tons. However, bioplastics made up only a small fraction, about 1.5 million tons or 0.6% of the total. Despite this, the market is growing, with long-term potential estimated at 20 million tons globally. As demand for sustainable materials rises, bioplastics are expected to play a bigger role. Bioplastics are already finding their way into many industries. In 2010, the main applications included agriculture and horticulture, packaging, bottles, consumer goods, and technical uses like electronics and automotive parts. Their versatility and potential for sustainability make them attractive for companies looking to reduce their environmental footprint. As technology advances, we can expect to see bioplastics in even more areas of daily life. When it comes to production, bio-based polyethylene BioP leads the way, followed by starch blends and polylactic acid PLA. These materials are being produced at increasing scales, especially as demand for greener alternatives grows. The development of production technologies and supply chains is crucial for making bioplastics more accessible and affordable for both manufacturers and consumers. Developing bioplastics isn't just about making new materials, it's about meeting the same standards as conventional plastics. Bioplastics must match or exceed the performance, reliability, and cost-effectiveness of traditional options. This means ongoing research in material development, processing, and quality control. Only by addressing these challenges can bioplastics become a true alternative in the marketplace. Meet industry needs. Bioplastics are often customized. This involves adjusting their appearance, mechanical properties, biodegradability, and durability. Additives, fillers, and reinforcing materials are used to fine-tune the final product. The goal is to create plastics that not only perform well but also align with sustainability goals, offering a balance between function and environmental responsibility. What happens to bioplastics after use? While many types can technically be recycled, the infrastructure and quantities aren't always sufficient. Some bioplastics are compostable, but not all break down in home composting. In many cases, energy recovery through thermal recycling is preferred, as bioplastics have a calorific value similar to paper. The end-of-life stage is a critical factor in the overall sustainability of these materials. Assessing the environmental impact of bioplastics involves looking at the entire life cycle, from raw material sourcing to disposal. Key criteria include climate impact, ozone formation, soil and water acidification, and effects on human and ecological health. While bioplastics often conserve fossil resources and improve CO2 balance, they may not always perform better in other categories like eutrophication or acidification. The results depend heavily on the specific conditions and choices made throughout the process. One common concern is whether producing bioplastics competes with food production. Globally, only 0.1% of arable land is currently used for bioplastics, compared to 2% for biofuels. Even if all plastics were made from bio-based sources, it would require about 7% of global arable land. Advances in agriculture and land management mean there's enough capacity to support both food and bioplastic production, especially with modern, efficient methods. Summary: bioplastics represent a promising step toward more sustainable materials. While they face challenges in performance, cost, and end-of-life management, ongoing research and development are closing the gap with conventional plastics. Using renewable raw materials makes sense for climate protection, resource conservation, and economic independence. With sufficient land and advancing technology, bioplastics are set to become an increasingly important part of our future.